I definitely have heard a lot more about Nix as things have been going on, especially as things like flat packs, maybe not snaps as much, but definitely flat packs have become a lot more popular as a way to deal with dependency management on these different systems. Usually you're going to have someone come along like, oh, we don't need something like that. Hey, we could use this instead. But I guess clearly there's a reason why people always come along suggesting Nix, right? Like it's not just people saying it because they just kind of feel like it. So I think the best place to start is, so there are two main things. There is NixOS, the distribution itself, and there is Nix, the package manager. I guess we should probably start with the package manager itself.
Yeah, so I actually want to start with the language because
Okay, sure.
the language is kind of what builds the basis of the package manager.
Mm,
So the Nix language, it's got, from what I've heard, similarities to Haskell. It
mm,
is a functional programming language, and you can kind of imagine it as a JSON with functions that spits out bash scripts. That's essentially what it
right.
does. You have very primitive things like attribute sets, lists, just your generic strings, and a little bit funky ones like paths and string context is numbers are another like regular thing. And then you have this funky type called a derivation.
Mm,
And derivation is really like a recipe. You
mm,
provide your derivation with an attribute set, and you provide it with things like the system uh, double. You provide it with a name and a builder.
mm,
And with those three components, it's able to call the builder and then spit out to some sort of output that is determined by hashing the attribute set.
mm.
And there's just some math in there that just does a funky hash, and it gives you this long character string where it's like nix slash store slash whatever garbage with the
Mm.
name attached.
Right.
And so essentially what you get is kind of like if you were to look at like a database and kind of like see everything has an ID,
Mm,
it's kind of like that,
mm,
but it's on your file system. And so this is kind of getting into where now we're talking about Nix instead
mm,
of just the Nix language.
mm.
And you can build up these concepts of just some arbitrary location that you're writing out to, and you can build up a packaging system.
Mm.
And by referencing one derivation into another derivation, you suddenly have dependencies. And if you track things correctly enough, you can build up a dependency tree. And then with that, if you just specify, I want this derivation that out of all the other derivations,
Mhm.
it's going to pull just that derivation and what other derivations that derivation needs.
Right.
So you get the concept of being able to pull its dependencies from referencing one package. Kind of like how when you do an npm install, it's going to pull all of its dependencies. But instead of going into some random directly like node modules,
Mhm,
it's going to your Nix tool.
mhm,
But with how Nix works, you don't need to be roots,
mhm.
unlike other package managers like apt or pacman, because it's in a Nix store. So now you suddenly have a way of installing packages without really installing them on the system.
Mhm.
And through that, we're able to have a package repo.
Right. So the Nix store, you use that term a couple of times. The Nix store is basically the location where the packages are stored, if that's correct, or the installed applications are stored.
Yeah, it's not really considered installing.
Mm,
There's a few different phases Nix goes through. You have evaluation,
mm.
then you have instantation. You go from there, and then you have either building or fetching.
Okay.
And the building or fetching is what it does to take what's called an instantiated derivation
Mhm,
and putting it into the store.
mhm,
And the way it does that is it'll check to see if your substitutors or one of your builders are available.
mhm.
And if it's already built and available, it's just going to pull it from whatever build system that you have remotely available or whatever other like caches that you have available as a substitutor.
Mhm.
And it just fetches it, puts it in the next door, and there you have it.
Mhm. So I always hear about Nix the handling dependencies and handling like installed versions in a better way than you would have in a more traditional packaging system. So through this system where you have these unique ID for your packages and it links to the other packages that uh, that package depends on, you can then have multiple versions of that on your system and it links to the different IDs for those different versions of the package. If that makes sense. If I'm saying this
Yeah,
correctly. I don't know
yeah,
the Nix
because
terminology, but if that...
yeah, so that's kind of coming from instantiation.
Mhm,
So evaluations is going to eval all of your uh, Nix code,
mhm,
and then
mhm,
instantiation, what it does is it tells the Nix daemon, "Hey, I have this attribute set that's being pushed to this derivation. Actually, make it a derivation."
mhm,
So then it takes all of that metadata associated, and then it assigns that hash.
mhm,
And through this, since every hash is arbitrary for is how that package is specifically written, if you change certain things, you can then get different versions of a package.
mhm.
So kind of you can even with like different packages that has different like build features. Like, hey, I want to build some browser without FTP support, or hey, I want to build something using GCC instead of Clang. You just specify that in, and because it changes that attribute set, it's going to change that hash, and then you suddenly have two different versions of the same exact package. They
Mhm.
could even be the same version of that package, but because they evaluate it differently, they have a different hash, which means they're going to be specified differently and not included together.
Mhm. So does this system work like all the way down, right? Like obviously it makes sense for, like your Firefoxes, things like that, but does this work at the level of something like glibc? Does it work at things like the Linux kernel level? Is there a point it breaks, or does this work all the way down the stack?
As long as you have some sort of arbitrary way of evaluating and being able to put a file somewhere,
Mhm,
you can pretty much put anything in there.
mhm,
Like even some of the concepts people have thought of is like doing machine learning models
mhm.
and splitting them apart and then putting them in the Nix stores because then you're able to have these large language models inside the Nix store and only pull the components you want.
Okay. I was not aware of that at all. Okay.
Yeah, this was actually a concept that was kind of thought of
Mhm,
during the recent conference in Pasadena called Planet Nix,
mhm.
ran by Phlox, where the idea is to split up these large language models because they're usually gigabytes in size, and you don't need everything. So if you have some sort of way of being able to build
Uh
it in,
Terabytes, I think you meant. Gigabytes is not that much.
yes, sorry, I meant I haven't worked much with these models, but they are file sizes that get difficult to download just because they're so large
Right, right, right,
and there's so
right.
many different components to them.
Sorry, I was just being pedantic. I just, go on.
I have California internet, and it's also great.
I don't, yeah, I don't know whose side it was then. Anyway, you were saying.
Yeah, so basically any sort of file works. There's a couple kind of files you don't really want to put in there, like device files or like sockets, but that makes sense because those aren't going to distribute easily. But any regular file, symlinks, those work. All your generic things works.
Mhm,
So we're able to put libcs, we can put compilers, we can put tarballs, we can do anything inside of a derivation,
mhm,
basically.
mhm. Right. Okay. So the Nix package manager itself, this is not something that has to be used on NixOS. This can be used on other systems as well.
Yeah, kind of like how you could use like Pac-Man uh, on Debian.
Mhm,
You can throw it onto any system, except for with other package managers, they kind of care because you're gonna have conflicts. If you just try to installing like Firefox from the Aurora onto a Debian system, you're gonna get some weird problems without trying to hack around the problem.
Sure.
But with Nix, because everything references each other, and because a Nix store exists, that doesn't matter.
Mm-hmm.
You can have a distribution of Nix OS or Nix packages, and multiple versions of that could be in your store, and they will never conflict because they all evaluate as their own things.
Mm-hmm. Mm-hmm. So how does this like interact with the distro? Is it like symlink it to where like you would expect binaries to be, or?
Yeah, so I want to explain a little bit more with how
Go right ahead.
NixOS works. So with NixOS, it takes that concept of a derivation and that it going to an output and assigning it to various things for Linux. And so it does things like setting up the etc directory. So like a very simple file to kind of think of one is the OS release file.
Mhm.
If you aren't aware, that's the file that contains the metadata that defines what distribution you're on. It's a very simple file format.
Mhm.
But because it's just a text file, you can make a derivation. And you can
Mhm.
have it just write some text and then symlink it to that
Mhm.
with a thing called an activation script. And this
Mhm.
is going a little bit more into how NixOS itself works.
Mhm.
You have what's called the top level derivation, which contains the stateless immutable build of your entire setup.
Mhm.
So it includes your graphics drivers, your kernel, even your bootloader. A little bit of that information is in there. And then all the rebuild script does is it just builds it and then runs the dry activation script, which is a script that is just the minimal amount of stuff to set up that top level derivation so that when you reboot,
Mhm.
you're going to get the next version that you've built.
Mhm.
And so that's how you can kind of set up etc. And with the activation scripts, you're able to do even weirder things like set up SC Linux, or you can have it do whatever because activation scripts are just a script.
Mhm. Okay. So I'm just trying to keep up with I'm trying to keep up with Mix here. For anyone who's not aware, I have like a surface level knowledge. I'm like learning as we're going here. I did a bit of stuff so I could like work out what to talk about, but like, you know, I might have to go back and rewatch this one to actually follow along with everything that's being said here. And I think this is one of the things with Nix and with NixOS. I A lot of people have, you know, you'll hear people talk about it, but you always hear people say, "Oh, it's difficult to learn. I don't understand how the system works," and it's a very different system than the way most distros work and most package management system works.